Hello 108 class, welcome to section 3.5. Mr. McHugh here with you. We're going to tackle functions. This is a new concept that from 025 we did not specifically get in details. If you had me for 025 in chapter 3, I would have talked about functions and introduce it here. This is a very important concept in algebra. You are going to see this a lot in 143, so I want to make sure you feel comfortable with the concept and how it works. Okay, now what I do in class, I usually like to turn around and get on the board, and I'm going to try to image you here. What's the concept of a function? It's a specific task that's being done. And I like to have you think about, in your kitchen, you have slices of bread. Bear with me here. You might have 2 slices of bread, and you're waking up and you like to have toast, and I'm looking at the top of the toaster, and you got a 4-slice toaster. If you take 2 slices of bread, you put them into the toaster, push the button down, what will come out when you're done? Now it sounds kind of simple, but you're going to get what? 2 slices of toast. Okay, so you had bread, it was your input, B-R-E-A-D, bread was your input, the toaster was your process, the output was 2 slices of toast. So a couple ways we're going to teach this to you here, but remember, input, process, output. That is what a function is all about. Okay, so let's go ahead and work down here through our notes here. You have your ordered pairs x comma y. Start getting used to the idea that x is your input. It is the independent variable. Think of input. And y is dependent, or the output. Okay, what's missing when you see an ordered pair is the process. Okay, so we're going to come up with an example here that you all guys can all relate to. Most everybody's out there working hard. Even if you're a hard worker mom, you still should be paid a couple $100,000, but that's beside the point. So what happens if you get an hourly rate and you get paid $8 an hour? So you can start making ordered pairs that for 5 hours of work, that could be your X, you would receive $40. How did we get the $40? The process was what? 5 times 8 to give you $40. Okay, so every ordered pair represents an input, some process that went on, maybe you know it, maybe you don't know it, and the output was the Y. Okay, so let's go ahead and go down here and work on objective 2 here. We've got a lot to cover here in this page, so I'll keep moving here. Okay, now, relations and functions, what's the difference? If you have a list of ordered pairs, by definition, they always are relations. It's just simply a set of ordered pairs. There's no requirements to them. They're always a relation. You have an input and you have an output, and it doesn't matter any requirements to it. Okay, now guess what? We don't really worry about that too much. What we're worried about here is the idea of a function. Now, a function is this: is a relationship that for every independent variable, for every input, you get one and only one output. Please listen to my words. For every input, you get one and only one output. Okay, exactly one unique dependent variable output. Example, a list of ordered pairs. Here's the key. Look at the X components. Are they all unique? If they are not all unique, then it's not a function. So everybody hear what I'm saying? Not a function. It doesn't matter what the Y's are. The X's must be unique. Okay. Now, I'm hoping here in this chapter you guys spend a lot of time here, this section 3.5. Read through this section in the book here or on your ebook to work with the class notes to really get this concept down. So the big thing we're going to work here in this class is all linear equations except vertical ones. And a vertical example would be what? Who remembers what a vertical is? Vertical equation would be like x equals 3. Wouldn't that produce 1, 2, 3? Wouldn't that produce a vertical line? Okay. So all lines except vertical are functions by definition, and that's because for every value of x that you choose, it's x is your input, you're going to put it into a value into the equation, say x equals 1. 1 times 2 is 2, 2 plus 1 is 3, and that was your output. So here's this function again, input, process, output. Okay, now what I like to do in my class, you're going to see this throughout a lot of the course here, I call these expanded XY tables. The book likes to just list X and just list the Y, and they start graphing, and they start writing domain and ranges, and people always get lost a little bit. Here's the story. You are going to choose a value of X. X is the input. If I say X is 1 like I just did, you take it and you input it into the process, into the equation. Notice I took 2x plus y, 2x plus 1 equals y, and I wrote it that way. Most of the times you see y equals 2x plus 1. Okay, there's nothing wrong with that. In fact, when you see the y isolated, that's telling you, that's a big hint that you do have a function. This is a linear equation because the exponent on the x is 1. So for every value of x that you put in, you get one and only one output. You get 3. If your x is 2, process it, calculate it, output 5. If x is 3, 2 times 3 is 6, plus 1 is 7, output is 7. 1, 3, 2, 5, 3, 7, all unique ordered pairs. Okay, now if I turned around, sorry, I'm going to move this down a little bit. If I turned around and graphed these, so this was my expanded XY table. Get used to doing these to get comfortable with the concepts being reviewed and learned here. If I plot these ordered pairs, 1, 3, 2, 5, 3, 7, I plot them. Notice they do form a straight line. How about this? Y equals mx plus b. What would the y-intercept be? Right there. Does that match up roughly? Sorry, I'm a little accurate. That would be 1. Okay. So notice now that for every value of x, if I come over here and go 4, I could come up, hit the line, and come across. But what I get if I put a 4 in, 2 times 4 is what? 8 plus 1 would be 9. The order pair would be 4, 9. Okay. Now, last thing, they like to use Venn diagrams. The idea is to draw circles. X is the domain. Okay, here's another new terminology. X is the domain. Now look at my graph here. How I remember this was X is horizontal, Y is vertical. D comes before R, X comes before Y. That's how you can remember that. Domain is input. Range is your output. Okay, and what's happening is these ordered pairs can be represented by a Venn diagram with these little arches. 1, 3 goes like that. 2, 5 goes like that. 3, 7 here. 4, 9 would be here. Now, this is all accurate information. I just want to show something. If there was, for some crazy reason, it's not part of the problem, but there was a 4, 15. If I was going to illustrate that on the Venn diagram, I would take the 4 and draw another arrow to the 15 to represent that. Okay, so a little more on Venn diagrams, but that's the idea. Now, this was not part of this problem, just an illustration. Okay, hey, Mr. McHugh here. We have wrapped up page 1, so we got more to do, so I will see you on page 2. Okay, goodbye.